Alright, let's take a look at the law of sines and cosines. Okay, so first thing you guys got to remember is the actual rules. If you have yet to write these down, you need to make sure you get them. Okay, so if we're thinking about the law of sines, basically the idea is you're connecting an angle with the side opposite, and what you can do is you can end up then creating fractions with them that you can use to draw those connections. So this and this together as a fraction will equal the other two. Okay, so you can use it when you've got one of those angles in the side opposite and you're looking for some other pieces. Okay, law of cosines is different. It's not the same as that. So with the law of cosines, it's mainly when you're trying to, like, we've got this side and we've got the other two sides, we can use it to find an angle. Or if we've got, those two sides and we've got the angle, we can use it to find the side. Okay, so it's kind of the opposite of law of sines in a sense. Okay, it just depends on what the way the equation is set up. That's really what, or the triangle set up, that really determines which one you can use. So let's take a look. Now these 4 problems, I'm going to do 4 problems. They're the 4 types of problems you have on your homework. I don't remember what numbers these are, but that's just, you can find them. So, and also the last one that says find the lengths, it just wants to make sure you're not solving the whole triangle. You just want to make sure that you're finding those side lengths that are missing. You will need to use a calculator with the sine, cosine, and tangent. Well, not tangent, but sine and cosine. So, this first one. So first we got to look at our setup. Okay, now it wants us to solve, so we need little b here, little a, and we've got little c, and we need angle c. So a lot of times it's a good idea to write these all out like this and put what we have. A is 72, B is 47, and then look and say, can we figure out C? Well, yeah, of course we can. Okay, we just go 72 plus 47, right? Because we know all triangles add up to 180. So that's 9, that's 11, so 180 minus 119 give us 61, right? So that's 61 degrees. 61 degrees. Okay, now we look for the connections we have. So I've got C and its side. So that's what I would call our anchor. Okay, we know that I can either write the sine of 61 degrees over C, or I can write C over the sine of 61. And I can set that equal to something. Okay, so the what determines which one you put on top is what we're looking for. Are we looking for any angles? No, we're not. We are just simply looking for these two sides. So we want to use this version. And then we just set it up. So equals, well, let's look for A first. And A is opposite 72 degrees, so we put A over sine of 72. Then to solve for A, we just put sine of 72, multiply both sides. And we know what C is, right? We should have put the number there, 12. So then in your calculator, you just type that out. You go 12 divided by the sine of 61 degrees, take that, and multiply the sine of 72 degrees. And we get about 13.05. Okay? So C we know is 12. A now we know is 13.05. Okay? It says round to the nearest tenth, so that'd be basically 13.1. I guess they're rounding to tenths. So 13.1. Actually, if we round it to the nearest tenths, that would just be 13. Okay? Now, you cannot use the Pythagorean theorem because we don't have a right triangle. So now we do the same thing, but this time we're looking for B. So B over the sine of 47 degrees. So I do the same process, times by the sine of 47 degrees, those cancel, times by the sine of 47 degrees, so we get B equals, and then we take our same problem basically and just change it 47. And we get 10.034, which rounded up is just 2. Okay? So there we go. There's our whole thing. So now if I wanted to, I could have just written this as, 13, 10, and 61 degrees. You can just write it in a triangle. You don't have to write this whole thing out if you don't want to. Okay, so that's one way to do it. Now let's take a look at this one. Let's actually make this a little bigger. There we go. So now if we look at this, notice I've already got an angle and I've got a side. And I've got a second side. Okay, so we've got little b, we've got little a, we still need little c. We can't use a Pythagorean theorem. We need angle C and we need angle A. Okay, so now we've got our anchor in B. So I know the sine of 98 degrees over 19 is going to be equal to what? Well, let's find A first. So now since we're looking for the angle, I put the angles on top and I put the sides on the bottom. But it's still the same process. Okay, first we start out by timesing by 14. So I have 14 times the sine of 98 degrees over 19 equals sine of A. Now you've got to remember, when we're looking for the angle, we actually do the inverse. So we're going to do the inverse of this whole thing. And this honestly is how I type it into the calculator. Saves you all that rounding issues. And that's going to give us angle A. Okay? So I do the inverse sine, which most calculators are easily able to do that. And I go 14 times the sine of 98 degrees. And I did the inverse sine first. And I take that and I divide it by 19. And that gives us, let's see, 46.8588. So we're rounded in nearest tenth. So that bumps it up to 46.9 degrees. Okay. Now, I could do the law of sines to figure out angle C, but I don't need, well, I actually can't because I don't know the side C, do I? So now we use that idea with angles. So I go 46.9 plus 98, take 180, divide that by my answer. I get 35.1 for that one. So that's easy to find too. Now we can do the law of sines one more time to figure out that last side for C. Could we use the law of cosine? Yeah, we could, but why would we want to when the law of sines is so pretty darn easy? So I'd go C over the sine of 35.1 is equal to, let's use our B again. It's easiest, 19 over the sine of 98 degrees. So notice now how we switched the sides. So we times by the sine of 35.1 degrees, and that's what we type in. So 19 divided by the sine of 98 degrees times the sine of 35.1 degrees, which gives us 11. So C equals 11.0324, so basically 11. And there we go. Okay, that's another way you're going to have to use it. Alright. Okay, let's take a look at two more problems. So these are with law of cosines. So now, law of cosines is a little different, right? Now we don't have any angles. We've got all our sides, but no angles. So we need to find an angle. So it doesn't matter which angle we use, just notice that the angle is going to have its side by itself. Okay, so let's just do A. So it's A squared equals B squared plus C squared minus 2BC cosine of A, right? Let's double check that. Yeah. So then we just get our information and plug it in. So this would be little c, little b, little a. You can't just arbitrarily assign those. That'll screw everything up. So we've got 22 squared equals 20.5 squared plus 25.8 squared, okay, minus 2 times 20.5 times 25.8 times the cosine of A. Okay? So let's start off. The easiest way to start off is first getting those and subtracting them from that. Okay? So, and we use our calculators a lot for this. So 20.5 squared is 420.25 plus 25.8 squared is 665.64. So add those two together. We get 1085.89 equals, now 22 squared is 484. So I take 484 and I subtract 1085.89. Now we still have this minus 2 blah 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 blah, all that stuff. We'll get to that, okay? So by subtracting by this on both sides, we get rid of all that, and so we're going to be left with whatever this is, equaling that negative 2 times 20.5 times 25.8 times cosine of A. Okay? So 44 minus 1085.89 gives us about negative 601.89. Okay? So negative 601.89 equals, so it's just a lot of calculations. Now we multiply all that. We can't put the cosine in yet. That's, what we have to do, undo. So negative 2 times 20.5 times 25.8 gives us negative 1057.8. And it's multiplied. So to separate it, I've got to divide both sides. Okay? So we've got the cosine of A equals negative 601.89 divided by negative 1057.8. Do that, and we get 0.5690017016. So then we're looking for the angle, so we take the inverse of that whole guy. You could round it to just 0.569001. But personally, I like to put as much as possible in there, and using the calculators, you can usually do that pretty easily. So I take the inverse cosine of that previous answer, and it gives me 55.3193, okay, which we're rounding to the nearest tenth, so it would be just 55.3. So a lot of work, right? And that was for A. So 55.3. Okay, so law of cosines takes a lot of work. A pretty straightforward problem, just very complex. Now we can use the law of sines to find another angle and then the thing. So usually you only use the law of cosines once, and once you have enough information you switch over to the law of sines. So we'd go the sine of 55.3 over 22 equals, let's find angle B, sine of B over 20.5. So I multiply by 20.5, those cancel. So then I'm going to get the inverse sine, right, because we're finding the angle of 20.5 times the sine of 55.3 over 22. That's going to give us what angle B is. Okay? So the inverse sine of 20.5 times the sine of 55.3 divided by 22 gives us about 50.0039, so basically 50. So there's 50, so then I just go 50 plus 55.3, right, to get our last angle, giving me 105.3. So take 180 and subtract that, and we get 74.7 degrees. Okay? So there we go. That's how we do it in that situation. Now the last situation we have is when you've got that angle with the two opposite sides. So now we're looking for little a. We've got little b. Oh my goodness, can't write a little b. Little c. Okay, so we can find little a. Once we have that, then we can use law of sines to find c or b, and then find the third that way. Okay? So I would go a squared, because that's what I'm looking for, equals b squared, so 27 squared, plus c squared, 13 squared, minus 2 times 27 times 13 times the cosine of 27 degrees. So this one, honestly, you can take that whole thing and just write it and get a squared. I'll do it kind of piecewise just to make sure you understand what's going on. So 27 squared is that. 13 squared is 169 minus 2 times 27 times 13 is 702 cosine of 27 degrees. So 729 plus 169 is 898. Now don't get in the habit of then taking 898, subtracting 702, and then multiplying. This needs to be multiplied first, order of operations. So this is where I just write this in the calculator. 898 minus 702 times cosine of 27 degrees. That gives me 272.51342 equals a squared. Then, using the calculator, we just take the square root of that, giving us about 16.507. So a is 16.5. Now we can use the law of sines. So I'd go the sine of 27 degrees over 16.5 is equal to, let's go for angle C this time, sine of angle C over 13. So we times both sides by 13. So we get 13 times the sine of 27 degrees over 16.5 equals the sine of C. And then to find C, we take the inverse sine of that whole thing. Okay? So I'd go the inverse sine of 13 times the sine of 27 divided by 16.5. And that gives us an angle C equals 20.958, so basically 21 degrees for C. So 21 plus 27 equals 48. 180 minus 48 gives us 132. And there we go. So I know that seems complex, and the problems are complex, but they're pretty straightforward. You just follow the plan and just use the law of cosines when you have to, the law of sines every other time, and as simple as you can make it, just go through the steps. So there we go.